Good evening, dear students. So in the last class, we have started with D and F block elements, right? So the same we are going to continue today. I think we have done some 10 questions in our previous class, right? Yes, so these are the things which we have covered. These are the questions which we have covered in our previous class. Okay, so yes, so from here, so we shall continue. Okay, yes, fine. I hope you have solved some questions. Okay. So whatever questions we have solved, so related same type of questions, if you find anywhere, I told you, okay, try to solve those questions. Okay. So that it will help you to practice. Okay. Fine. So let us continue with the questions. So the next question is 12th question. Okay. In a transition series, okay, in the transition series, with the increase in atomic number, the paramagnetism, okay, what happens to paramagnetism? A, increases gradually. B, decreases gradually. C, first increases to a maximum and then decreases. D, first decreases to a minimum and then increases. Okay, now we know what are transition series. Okay, D block elements are called as transition series. So as you proceed from left hand side to right hand side, okay, what is happening? There is a increase in atomic number, okay, of the elements. That is, if you take from scandium, okay, so scandium onwards to zinc. Suppose if I give you that example, okay. So what happens in the transition series with the increase in atomic number? What do you mean by paramagnetism, students? Yes, what do you mean by paramagnetism? So what happens to paramagnetism? They have asked. What happens to paramagnetism? Any idea about what do you mean by, okay, more number of unpaired electrons are present. Okay, Shri Varuni has answered it. More number of unpaired electrons are present. Now, how does paramagnetism affects? Okay, how does paramagnetism affects? Now, suppose, so now suppose we have some, just I'll take, now here, okay. So paramagnetism, there is diamagnetism, right? Ferromagnetism. So these are what? These are the form of paramagnetism. These are the form of magnetism. Okay. Now what happens here? So some materials, okay, some of the materials, they are weakly attracted. Okay, they are what? They are weakly attracted by the external magnetic field. So in paramagnetism, what is happening? So some of the materials, they are weakly attracted by the external magnetism. Okay, external, whatever the external magnetic field you are applying. So the materials are weakly attracted. They are not completely attracted. They are not strongly attracted. They are weakly attracted by the external magnetism. Okay, so what happens? So because of these, okay, so here you can see, so paramagnetic substances, they are said to be what? They are said to be having the unpaired electrons, okay, unpaired electrons in their valence shell. So as you move from left to right, so what will happen to the paramagnetic behavior? So paramagnetism is shown by the elements which are having unpaired electron. Unpaired means what? When you have single electrons, okay, when you have single electrons, there is no pairing taking place. So what will happen? Yes. Okay. Shri Varuni has answered it as C. What about others? What about others? Try to answer. What is the answer for this? Okay. Akhila has answered as A. Yes. Akhila has answered as A. Okay. Ummehani has answered as A. Fine. So let us see now what will happen here. So when we see that, when we tell that in a transition series with the increase in atomic number, the paramagnetism. So what will happen to paramagnetism? The paramagnetism will first increase. Okay, it will first increase. Okay, why? Due to unpaired electrons. So due to increase in the unpaired electron. So as you proceed from left to right, what will happen? There will be increase in the number of unpaired electrons. After chromium, okay, after chromium, what will happen? The number of unpaired electrons will decrease. Okay, so first, if you see across this, so the unpaired electron increases. Okay, so because of that, the paramagnetism also increases. After chromium, the number of electrons, unpaired electrons will decrease, and what will happen? Paramagnetism also decreases. So option number C. Okay, option number C is the correct answer. So whoever has answered as C, so C is the correct answer. Okay. So what will happen? So in the transition series, with the increase in atomic number, first it increases to maximum because the electron, number of electron, unpaired electron are also more. Okay. As you proceed from left to right, and after chromium, the number of unpaired electron decreases. Because of that, your paramagnetism also decreases. So option number C is the answer. Remember this. Okay. Next, we will see the correct statement is. So there are four statements you have to tell which is the correct statement among the following. Okay. Now here, the first statement is the earlier members of lanthanide series resemble calcium in their chemical properties. B, the extent of actinoid contraction is almost the same as lanthanoid contraction. C, in general, lanthanoids and actinoids do not show variable oxidation state. And D, cerium plus 4 in aqueous solution is not known. So which is the correct statement among the following? Yes, try to answer. Which is the correct statement among the following? So apply your knowledge about the lanthanoid, actinoid, okay, and try to answer this. So the extent of, okay, when you see the actinoid contraction, it is almost the same as of lanthanoid, okay. Here, 17. Okay. Now your the external contraction, it is due to what? It is due to the it is due to the what? Here you can see there is intervening of 4f orbitals, it is intervening of 5f orbitals. So it is not same, almost same. So this is a wrong statement. Then when we see lanthanoids and actinoids, they do not show variable oxidation state. Okay, but they show variable oxidation state. So this is also a wrong statement. And cerium plus in aqueous solution is not known. Cerium is stable in cerium plus 4 state. Okay, it is most common oxidation state of cerium. So this is also a wrong statement. Okay, it is not known. No, it is known. Okay, so this is also a wrong statement. So it is the most commonly formed oxidation state of cerium is plus 4. So these are the three are the wrong statement. When we see the A, okay, the earlier members of lanthanoid series resemble calcium in their chemical properties. Yes, so this is the correct answer. So option number A is the correct answer. So who all have answered as A? Akila has answered, Shivaruni has answered. Okay, so answer option number A is the answer. Okay, let us go for the next one. On heating potassium permanganate, one of the following compound is not obtained. On heating potassium permanganate, one of the following compound is not obtained. Yes, A MnO, B K2MnO4, C O2, and D MnO2. Yes, what is the answer? On heating potassium permanganate, which of the following one of the following compound is not obtained? Yes, suppose I'll write the reaction. Okay, so KMnO4, if I heat this KMnO4, so what will happen when I heat KMnO4? 2 KMnO4, okay, so it will form K2MnO4, K2MnO4 plus, okay, then Mn, so K2MnO4, now one more left is MnO2 plus O2. So what is not obtained? Yes, MnO is not obtained. Okay, MnO is not obtained. So option number A is the answer. Akhila has answered it right. Okay, option number A is the answer. So what is not obtained? MnO is not obtained. So when you heat potassium permanganate is what? It is a good oxidizing agent. So when you heat potassium permanganate, you obtain K2MnO4 plus MnO2 plus O2. Okay, so this is the reaction. So A is the compound which is not obtained when you heat potassium permanganate. Okay, next question. 15th question. Mn plus 2 compounds are more stable than Fe plus 2 compounds towards oxidation to their plus 3 state. Because what is the reason why Mn plus 2 compounds are more stable than Fe plus 2 in their plus 3 oxidation state? A, Mn plus 2 is more stable with high third ionization energy. B, Mn plus 2 is bigger in size. C, Mn plus 2 has completely filled d orbital. D, Mn plus 2 does not exist. Yes, what is the answer? Why Mn plus 2 compounds are more stable? Why Mn plus 2 compounds are more stable as compared to Fe plus 2 in their plus 3 oxidation state? When we see Mn, okay, when we see Mn, try figuring out. Mn is 25, right? Mn is what? I'll write it here. So Mn, the atomic number is 25, Fe is 26. Okay. So if I write the oxidation state, okay, if I write the oxidation, this electronic configuration of manganese, it is what? Argon, argon 18, okay, then 3d5 and 4s2. Okay, and if I write for Fe, it is argon 3d6 and 4s2. Right. Now, if I write the plus 2, okay, in Mn plus 2, it will be argon 18 and 3d5, and Fe plus 2 will be what? Fe plus 2 will be what? It will be argon, okay, 3d6. Right. Now, the compounds towards their plus 3, Mn plus 2 are more stable than Fe plus 2 compound towards the oxidation of to their plus 3 state. Okay. Now, when we write here for Mn plus 2, okay, now in Mn plus 2, if I see that when I write the electronic configuration and for your 1, 2, 3, 4, 5, this is Mn plus 2, this is Fe plus 2. Now, if I feel the electrons, here there are 5, right? So it will be 1, 2, 3, 4, 5. And here, how many? 3d6. So 1, 2, 3, 4, 5, and 6. Okay, what you can see here? Akhila has answered as A. Okay. So what you can see here? Here you can see that, okay, as compared to Mn plus 2 and Fe plus 2, okay, Fe plus 2 here, Mn plus 2, the electrons, okay, whenever you see that, whenever you have half filled, okay, whenever you have half filled electronic configuration or fully filled electronic configuration, that is, whenever you have D5 system or D10 system. Okay, what it is said to be? It is said to be completely stable, right? Remember this. So whenever you have a half filled means what? Singly filled electrons. Okay, there are 5 electrons. That is, whenever you have a D5 system or completely filled means what? All there should be 10 electrons. So whenever you have a D5 system or D10 system, okay, so it is said to be more stable. So Mn plus 2, it has what? It has half-filled electronic configuration. So if you want to remove the third electron, now what it is said now, Fe plus 3. Okay. Now if I want to remove the third electron, now from where I should remove the third electron? From the D5 system. Now what I said just now, that whenever you have a half-filled system, they are more stable. Okay, now to remove the third electron from here, it is very difficult. Okay, it is very difficult. Why? Because it is completely stable. It is in its most stable form. So to remove the third electron, it is very difficult. But in Fe plus 2, okay, in Fe plus 2, to remove the third electron, it is quite easier. Okay, after removing the third electron, then it will be in its what? It will be in its more stable state. Okay, then it will have a D5 configuration. So what is the answer here? So Mn plus 2 is more stable with high third ionization energy. Okay, so option number A is the correct answer. So it is more stable. So when you are removing the third electron, it is very difficult because it is in its more stable state. So option number A is the correct answer. So whoever have answered it as option number A. Okay, Akhila has answered, Sri Varuni has answered. Very good. Okay, so I hope you have understood. So remember that whenever you have a half-filled system or completely filled system, they will be in its more stable state. Okay, it will be in its more stable state. What do you mean by ionization enthalpy? Okay, what do you mean by ionization enthalpy? Ionization enthalpy means what? It is the minimum amount of energy which is required to remove the electron from its isolated gaseous atom. Okay, so if you want to remove the electron, now if I want to remove the electron from its outermost shell, now, okay, so if the electron is, suppose if I am talking about sodium, okay, if I am talking about sodium, sodium is 11, so it is 1s2, 2s2, 2p6 and C3s1. Okay, now, so here, so let us put the electron filling. Okay, now let us put the electron. So now here, first I have what? 1s2. Okay, 1s2. So here 2 electrons are there. Okay, there are 2 electrons. Then what I have? 2p2 and 2s2 and 2p6. So 8 electrons. So 1, 2, 3, 4, 5, 6, 7 and 8 electron. Now in the third orbit, okay, next orbit, you have only 1 electron. Now, now if I give, if sodium, if the sodium, if it gives this 1 electron, if the sodium gives this 1 electron, what are the next electronic configuration? It will be what? It will be 8, okay, octet. So it will be in its octet state. So whenever we know that whenever any element, okay, it is in its octet state, it is said to be what? It will be in its most stable form, right? So now here, what sodium will do? Sodium, it will give this 1 electron. Okay, sodium will give this 1 electron and it will be in its +1 state. So now if the electron is removed, so this is the minimum amount of energy. So now ionization enthalpy means what? The energy which is required to remove the electron from its outermost isolated gaseous atom. Now to remove this electron, it is very easy. But if you want to remove the next electron, now the next electron is to be removed from what? It has to be removed from this system, right? 2s2, 2p6. Now here it is in its completely octet form, octet state. Now here the nucleus is in center, and what the nucleus will do, it will hold the electrons more this, right, tightly. Electrons are what? Electrons are negatively charged, and the nucleus is what? It is a positively charged. So whenever you have negative and positive, So there will be a force of attraction which is holding the electrons. So this nucleus will hold the electrons very tightly. So whenever you are removing the first electron, it is the minimum energy. But when you are removing the next electron, it is very difficult. Okay, so we say that the second energy, okay, if I am removing the second electron, so the ionization enthalpy of second electron, it will be more as compared to I1. Now suppose I want to remove the third electron. Okay, third electron. Now third electron, if I am removing, then what will happen to the ionization enthalpy? Again, it will be more. So IE3 will be more than IE2. Okay, so this is the ionization enthalpy or ionization energy concept. Okay, so the minimum amount of energy which is required to remove the electron from an isolated gaseous atom. Okay, so if you are removing one electron from its outermost shell, now here, okay, so it is quite difficult because it is little far also from the nucleus. Okay, but when you are removing the electron from this system, okay, so because there are already 8 electrons and it is in its octet state, so it is quite difficult. Okay, so that time the energy required will be quite high. Okay, remember about ionization enthalpy, very important concept. Okay, in your first year also, you might have studied about this concept, that is ionization energy. Okay, so ionization energy is very important concept. It was taught in classification of elements, okay, and periodic properties. Fine. So let us go for the next question. Which one of the following statement is wrong regarding lanthanoids? So which of the following is wrong regarding the lanthanides? A, Ln, three compounds are predominantly ionic in character. B, Ln3 hydroxides are mainly basic in nature. C, the ionic size of Ln3 ions decreases with increasing atomic number. D, Ln3 compounds are generally colorless. Okay, so lanthanoids. Okay, so when we are talking about lanthanoids, so which is the wrong? Okay, so there are four points given here, four statements given here. So you have to tell which is the wrong statement about the lanthanoids. Yes, we have studied this in our theory part about lanthanides. So just recall the things about lanthanides and try to answer about lanthanides. So which is wrong? Okay, Sri Varuni has answered as B, Sanjuta has answered as C. Okay, now when we see Akila has answered as D. Okay. Now here, when we see that lanthanoids, okay, lanthanoids. So in lanthanoids, so most of the elements they are in commonly oxidation state is +3. Okay, the common oxidation state of these lanthanoids, they are trivalent. They are said to be what? Trivalent ion. Okay, they are trivalent in nature, or you call it trivalent ions. Okay. Now, and these all trivalent ions, they are what? They are colored. Okay, they are in colored form. They are colored. Okay, they are not colorless. They are colored. They are colored in both in the solid state also, as well as in the aqueous state or the solution state. Okay, and why the color of the elements will exit? Yes, why the colors of the ions will exit? Because they will absorb the radiation, right? They will absorb the light from the visible region. Okay, and it will undergo what? It will undergo FF transition. So because of the FF transition, so the lanthanoids will have partially filled F orbital. So the wrong statement among the following is that Ln3 compounds, they are generally colorless. No. Okay. The lanthanoid, when they are present in +3 state, okay, because most of the lanthanides, they are trivalent ions, okay, and these trivalent ions, they are colored in both the solution form as well as the solid state. Okay, so what they do, how the color is observed, they will observe the light from the visible region. Okay, and FF transition takes place, and because of that, there will be partially filled or f orbitals will be present. Okay, so option number D. So our answer is option number D. So whoever have answered option number D, okay, is the correct answer. Sanjuta has answered. Okay, then Akila has answered. Fine. So this is the correct answer. So let us go for the next one. Which of the following oxidation states is common for all lanthanides? +2, +3, +4, and +5. Yes. Which is the common oxidation state of the lanthanoids? Just now we have discussed which is the common oxidation state of lanthanides. Remember that. Okay, very important. Which is the common oxidation state? +2, +3, +4, and +5. Yes, very good. Okay, so it is +3. Yes, Sanjota, Sri Varuni, very good. So it is +3. Okay, remember that. So the common oxidation state shown by the all the lanthanoids is +3 oxidation state. Okay. So option number B is the answer. Next question. KMnO4 acts as oxidizing agent in alkaline medium. When alkaline KMnO4 is treated with Ki, iodide ion is oxidized to A, I2, B, IO minus, C, IO3 minus, and D, IO4 minus. Yes, so we know that KMnO4 is what? It is a good oxidizing agent. So what will happen to KMnO4? So when it is treated with Ki, yes, what it will happen? What are the reaction? So if I write, it is acting as oxidizing agent in alkaline medium when KMnO4, okay, if we are treating with what? We are treating it with Ki. Okay, we are treating it with Ki. So let's see what will be the reaction. So it will be 2KOH plus 2MnO2 plus KiO3. Okay, KiO3. So it is IO3 minus. So option number C. Okay, option number C. Yes, Shivaruni has answered. Okay, fine. So yes, option number C is the answer. So KMnO4, it acts as oxidizing agent in the alkaline medium. So when you treat the KMnO4 with Ki, this is a reaction which is occurring. So it is what? IO3 minus. Okay, it is IO3 minus. Fine. So this is all based on the reactions. Okay. Next one.
Hello.
So the elements in which electrons are progressively filled in 4f orbital are called. The elements in which the electrons are progressively filled in 4f orbital are A, actinoids, B, transition elements, C, lanthanoids, and D, halogens. Yes, very easy question. Very easy question. Yes, when the electrons are filled in the 4f. Yes, very good. Akhila, Sanjota, Srivaruni, Umehani. Okay, very good. It is C. Okay, it is C, lanthanoids. So they are so when your the electrons are filled in the 4f orbital. Okay, then they are termed as what? They are termed as the lanthanoids. Okay, they are termed as what? Lanthanoids. Yes, very good. Akhila, okay. Let us go for the next one. Incorrect statement with reference to cerium. Okay. Incorrect statement with reference to cerium whose atomic number is 58. A, cerium +4 is a reducing agent. Cerium in +3 oxidation state is more stable than in +4. atomic size of cerium is more than that of lutetium. Cerium shows a common oxidation state of +3 and +4. So which is the incorrect statement among the following about cerium? So the cerium, okay, cerium is a not reducing agent, it is a oxidizing agent. Okay, cerium is a oxidizing agent. So
Option
A is
C.
the answer. When you compare your
Option C.
this, okay. So cerium, it is what? It is a oxidizing agent and not a reducing agent. So option number A is the answer. Okay, what is the answer? Option number A is the answer. So cerium in its +4 state, it is it is not a reducing agent, it is a oxidizing agent. Okay. So identify the sets of paramagnetic ions among the following. So there are 3 ions in each option. So you have to tell which of the set of paramagnetic ions are there. Okay, paramagnetic means what? There should be presence of unpaired electrons. Okay, there should be presence of unpaired electrons. So try to answer this. Very easy question. Very easy question. What you need to know here, you need to know the this, okay, atomic number. So nickel is 28, copper is 29, zinc is 30, Mn is 25, cobalt is 27. Yes, find out. Titanium is 22. Then you have scandium. Scandium is 21. Palladium. Vanadium is 23. Okay. Sri Varuni has answered as B. Akila has answered as B. Okay. So now here, when you write the electronic configuration in nickel +2, so it will be 3d8 here. Okay. And your copper. So copper in its +2 state, it will be what? Copper in its +2 state, it will be 3d10 4s 3d10 4s1, no? So it will be 3d9. 3d9.
Option C. Option C is correct.
Zinc.
Option C. Option C.
Okay. So here, titanium. So if I write for titanium, so titanium will be 3d2 4s2. Okay, when +3 state, they have asked for +3 state. So in the +3 state, it will be 3d1. So 3d1. So here also one electron is present. Okay, now in its your copper in +2 state, then manganese. Okay, manganese in +3 state. So write for all and just check. So if I write for Mn, so Mn 25, so it will be argon, argon 318. Okay, then 3d5 and 4s2. So Mn +3 will be what? It will be 3d4. Okay, it will be 3d4. Now here 4 electrons are present. Then if I write for titanium plus 3, okay, titanium plus 3. So titanium is what? It will be argon 18, 3d2, 4s2. So when it is titanium plus 3, it will be 3d1. Okay, so here 1 electron is present. Then copper plus 2. Copper plus 2 is what? Copper plus 2 again here will be in copper, it will be argon 18, 3d10, 4s1. So copper plus 2 will be 3d9. So here also, how many electrons are present? 1 electron is present. So option number B is the correct answer. So if I write for all, okay, if I write for all, so just check, it will be option number B. So what you have to do? You have to write the electronic configuration of all. Okay, you have to write the electronic configuration for all. As now, suppose if I have to write for nickel. Now nickel will be how now? Okay, the answer is B option. But now nickel is 28. So it will be argon 18. Okay, 3d8 and 4s2. Then nickel in its plus 2 state is what? It will be 3d8. So if I write the 1, 2, 3, 4, 5. So it will be 1, 2, 3, 4, 5, 6, 7, 8. So here 2 electrons are present. But the complete set should have the plus 2. Okay. Now when I write for copper, copper will be again here 1 electron is present. Okay. So here also 3d9 system it will be. So 3d9 system means 1 electron. Here again it is present. Here 2 electrons. Now one more is zinc. Zinc will be what? Argon 3d10 and 4s2. So if I write for zinc plus 2, it will be 3d10. So it is completely filled. So this is wrong. Okay. So same way for C and D also you try. So one of the element will be completely filled. So complete set they have asked. Okay, set of paramagnetic ions. So option number B is the answer. So if I write the electronic configuration, okay, if I write the distribution of ions, so we see that option B is the correct one. So all the set of ions are having what? They are having unpaired electrons. Fine. Next question. Which of the following pairs has both the ions colored in aqueous solution? Okay, so which of the following pairs has both the ions colored in aqueous solution? So atomic numbers are given of scandium, titanium, nickel, copper, and manganese. Yes. So for the ions to be colored, okay, for the ions to be colored, what is the necessary condition? It should undergo DD transition. Okay, it should undergo DD transition. So if there are no DD transition or if there is 0 electron, then it becomes colorless. So at least at least any electron should be present. Okay. Now here, what is the answer? So if I write for titanium, so let us write for scandiums first. Scandium is 21. So it is argon 18. Okay. Then you have Mn 25. That is argon 25. 25. Now here you have nickel 28, argon 18, 3d8 and 4s2. Then you have titanium. Titanium is 22. So you have argon 18, 3d2 and 4s2. Then you have what? Titanium plus 3 over titanium plus 4 is also there. Here also I'll write. Then copper. Copper is there. 29. So it is argon 18, 3d10 and 4s1. Okay. So let us write now. Let us write. So scandium in its plus 3 state, it will be what? Scandium will be 3d0. Okay, because all the electrons are gone. So it will be 3d0 system. Then Mn plus 2. Mn plus 2 will be 3D phi system. Okay. 3D phi system. Mn plus 2. 3D phi system. So 2 electrons will be lost from here. Then what? Nickel plus 2. Here it will be 3D8 system. Okay, how many electrons are there? That we will see. Okay. Now here, if I write the electrons for Mn, 1, 2, 3, 4, 5. So it will be 1, 2, 3, 4, 5. So here you can see that all the d electrons, okay, they are occupied by one unpaired electron. Okay, so it is perfectly octahedral. So here, so because of this, it will have a color, okay, pale color, pale color. So this is colored system. Now, next is nickel. Nickel is 3D8. So if I write the electronic configuration, so 1, 2, 3, 4, 5, 6, 7, and 8. So here you have 2 electrons. Okay, D2 system you have. Then titanium plus 4. It will be titanium plus 4 will be 3D0 system. Then titanium plus 3. Titanium plus 3 will be your 3D1 system. Okay. Then you have copper plus 1. So it will be 3D10 system. Then again, which you have, so here. So what you can see here, option number Mn plus 2 is what? It is, so which is having colored. Okay, scandium here is colorless. So this is wrong. Okay, it is a 0 system. Then nickel plus 2, here you have 2 electrons. By titanium, here it is 0 system. So this is also wrong. So this is colored, but this is not colored. Then titanium plus 3, 1 electron. But here you have 10 electrons. So again, 0 system. So this is also wrong. Mn plus 2, 5 unpaired electrons. So this is okay. Titanium plus 3 plus 1. Okay, so it is option number D. So for the DD transition, what is the necessary condition for the DD transition? At least, okay, unpaired electron should be present. So for the ions to show colored property, it should have unpaired electron. Okay, there should be no 0 system. If you have 0 electron, that means they are colorless. Okay, they are colorless. I hope this is clear. I hope this is clear. Okay. Next question. A transition metal exists in its highest oxidation state. It is expected to behave as A, an oxidizing agent, B, a reducing agent, C, a chelating agent, and D, a central metal ion in its coordination compound. Yes, transition metal, whenever it is having highest oxidation state, so it behaves as what? Yes, it behaves as what? It take KMNO4. Take KMNO4. If I want to find out the oxidation state of Mn, so this is +1 plus X plus 4 into -2 equals to 0. So it is 1 plus X minus 8 is equals to 0. So X minus 7 is equals to 0. So X is equals to 7. So here what you can see, because KMNO4, when you see KMNO4, the oxidation state of Mn is +4 plus 7. And you can see that KMNO4, it is a dark colored. It is having a dark purple color, right? So transition elements, whenever it is having highest oxidation state, it behaves as what? It behaves as a oxidizing agent. Okay, so option number A is the answer. We know that KMNO4, it is oxidizing agent because it is having a highest oxidation state. Is it clear? Okay, fine. So any doubts up to here? So we have seen nearly 12 questions today. Okay. So few more questions. So in the next class, we are going to take. So any doubts up to here? Yes. I hope you have understood all the questions. Very simple chapter this is. Okay. So concept should be clear. So this is all theoretically. So theoretical. Okay. So if the concepts are clear, so you can easily deal with the questions. Okay. So if you, so please try to please try to solve much questions on these chapters. Okay, so these are some of the scoring chapters. By on theory basis, you can crack these questions. Okay, so yes, so by this, okay, fine. Then there are no doubts. Fine. So by this, I shall end the session here. Okay, so we'll meet in the next week. So one more class I'll be taking. Fine, on this chapter, on this particular chapter. Okay, and then we will start with the next one. Fine. So thank you. So I shall end the session here. Okay. So thank you. We'll meet in the next week. Thank you.